Chapter 18 is going to be about the law of increasing disorder. Now, based on the name, you can tell that this law says that disorder is always going to increase. In the universe, we have a certain amount of order, but that is always becoming less and less. Things are always becoming more and more chaotic. This chaos is called entropy. So I have written up here that entropy always increases. You can think of your bedroom and how, as you live in it, it's always getting messier and messier and messier. And in order to get it clean, you have to put in work. And that work actually is going to increase the entropy further because work is going to increase entropy. So as you go from like a solid to a liquid to a gas, because the molecules are going faster and faster, that's also going to increase entropy. So here we have our energy alien picture that we've used before. We have our different energies. We have kinetic potential energy, because the eyes move back and forth, right? Gravitational potential energy. Elastic potential energy is the tongue. Then we have his neck, his NEC, his nuclear potential energy, electrical potential energy, and chemical potential energy. Down here we have his heart, his thermal energy. Thermal energy is any heat, light, or sound that's going to be released as part of a reaction. So here's our energy alien. The one part that we added to this picture is here on the right, where most ordered is at the top and least ordered is at the bottom. So we have conservation of energy through all reactions, right? Total energy is always going to be conserved. But the kinds of energies, of course, are not going to be conserved. And always, because entropy always increases, we're going to be going down this energy alien to something least ordered, okay? So something more towards thermal energy or chemical potential energy. Good way to remember this is most ordered, and that's at the top, because things make a lot of sense in your brain. It's more ordered, right? We have least ordered down here by the heart. Sometimes if you like someone or you're in love, it doesn't really make sense, and so it's less ordered, right? So with our fridge example, the point of a fridge is to separate the hot molecules and the cold molecules. Going back to the bedroom or the playroom example, we have to put the cars in one drawer, we have to put the blocks in another drawer, right, and make it more ordered. So we use this compressor and send the hot molecules out of the fridge. In order to do this, we have electrical potential energy going to thermal energy, right? Has to do that because it needs to go down in order to go with the law of increasing disorder. The entropy is always going to increase. With that, we also have kinetic energy that's being created because these hot molecules are moving out. So we kind of have this conundrum here because we have the fridge, which is becoming more ordered, and this electrical potential energy, which is going up to kinetic energy. So it would seem that things are becoming more ordered, but that's just within the fridge. Overall, we have an increase in thermal energy, as well as the hot molecules, which are being moved outside of the fridge, creating an overall net increase in entropy. So the system's entropy might decrease as you clean something up, but overall the universe entropy is always going to increase. So in conclusion, we have reversible and irreversible reactions. Now, irreversible reactions are going to be ones that if you played backwards, it wouldn't work, right? So we have this diver jumping into the water. If you played that backwards, that wouldn't really mesh up, right? It wouldn't look normal. Whereas reversible reactions, you could play it backwards and it would make sense. So here we have the reversible reaction of the diver. We start off with gravitational potential energy, turns into kinetic, and then he hits the water, we have friction, and then the water is going to move. So we're going to go down the energy alien and become something less ordered, okay? A swing is going to be a little bit more reversible, because if you played that backwards on a movie, I guess, it would appear that it's reversible. But the reason it's not, the reason it's irreversible, is you can't put that energy from his pumping his legs back inside of his body. That's already gone and done. The closest thing we have to a reversible reaction is water freezing and melting at the same rate. That's the closest thing we have to a reversible reaction. And with these reversible and irreversible reactions, Entropy is going to increase the most with irreversible, and entropy is supposed to stay the same with reversible reactions. But there's no real reversible reactions because entropy is always going to increase.